Now, very good morning to all of you. Today, as you know, I'm going to take few more questions, and today I have chosen some problems of two dimension. So, the very first problem which I am going to do is to find the moment of inertia of a triangle ABC about a perpendicular to the plane through A. So, a triangular lamina, that means a two-dimensional body is given to you in the question, and what is asked? Find its moment of inertia about a perpendicular to the plane of the blackboard passing through A. So that means about the axis AK, we have to find the moment of inertia of the triangular lamina. Now, of course, it's not very simple question, but let us do. We are going to use the theorem of parallel axis here. So first of all, as you know what we do, draw the figure ABC and consider a elementary mass portion that will be in the form of a strip. So elementary strip we will consider will be PQ. It is at a distance x from the vertex and its width is delta x. This is what we are doing very often in every question. So its mass will be, let us assume that this AN is x and AO, that is the height of the triangle, is h. You can see that this triangle APQ is congruent to similar to ABC. So these are the two similar triangles. So we are going to use the property of that. That means height of this triangle divided by height of the big triangle. That will be the base of this triangle divided by base of the big triangle. Now why we are doing this? You can observe that PQ is a unknown quantity and we want to find it. That is why we are doing it. So x divided by h is PQ divided by BC. Now conventionally we write BC as a small a. All of you know in a triangle the side opposite to the big angle capital A is denoted by a small a. So this side BC, it will be denoted by a small a. So that gives you the value of PQ. PQ is AX divided by H. Why we are interested in PQ? Because we have to find the mass of this elementary strip. And mass of this elementary strip, it is in 2D. That will be density times area. So width is known to you. Width is given as delta x. So its mass will be AX divided by H into delta x. So the total mass, you have so many elementary strips. One is placed here, one is placed here, one is placed here, like this. So you have so many elementary strips. So you will get the mass by multiplying, this must be H, not A. So this will be AH rho divided by 2. That will be the total mass of the triangular lamina, for which you are calculating the moment of inertia about an axis passing through one of its vertices, passing through A and perpendicular to the plane of the blackboard. I hope the question is clear to all of you in your mind. So moment of inertia of this strip we will calculate, and then we will integrate to get the total moment of inertia. Now the integration will be 0 to h. Why 0 to h? Because you can see at a distance x you have considered the strip, and this varies from 0 to h. You can consider another strip like that. So the integration is within the limits 0 to h. So you can put the values and then you have to integrate. Now here we are using the main result, that is moment of inertia of this triangular lamina about this axis is the sum of two quantities. What are those two quantities? One is moment of inertia about an axis passing through M and perpendicular to it, this moment of inertia, plus mass and then this perpendicular distance is square. So that is what we are, this AM perpendicular distance is square. So that is what we are using. It is moment of inertia about a line through M plus mass of the strip into the perpendicular distance square, that is AM square. So this is what the theorem of parallel axes says, and that is what we are going to use here. Now again the next thing is simple, just substitute the values. Moment of inertia, this is a rod whose length is now known to you, it is PQ. So you are using the formula of moment of inertia of a rod about an axis passing through its center and perpendicular to it. Is that clear? So it will be 1/3 of MA square, where you was taking A as the length of the strip, 2A is the length of the strip, but here it is length of the strip is PQ, so it should be divided by MA square by 3, so it should be divided by 2. So that is why it is AX divided by 2H. What is this? Half of the length of the strip. Okay, so this is moment of inertia, this is first term. Second term is mass. Mass is like this, multiplied by perpendicular distance square. Now again one important result I am going to use, that is AM divided by AE is X divided by H. You can see this is AM, this is AE is equal to X divided by H. From where you are getting? By the similarity of the triangles AMN and AOE, isn't it? So from there you can find the value of AM. So AM is coming as X upon H into AE. Now why we are putting in terms of AE? There is no harm in putting in keeping AM, but you can observe that the strip which you are taking is dependent on AM, whereas AE is independent. So you can take AE outside the integration. You can choose the strip anywhere. AM will be affected, but AE will not be affected. Is this point clear? Okay. So that is what we have to do. We will substitute the values. We will take AE square outside. We will integrate and we will put the limits. So that will give you M upon 24 A square plus 12 AE square. From where I have obtained m? From this very equation. So, one way we have done it, but we have to simplify. Sometimes the result is also given and it is asked to find in that form. So, let us simplify it. That means we have to find the value of AE in the triangle ABC. So, you can observe AE square is nothing but AO square plus OE square, because it is a right angle triangle. So, sum of this plus this will be this square. Now, what is this OE? OE is nothing but BE minus BO. So, this is what I did. Why? Because we want to convert it in terms of known quantities. And what are the known quantities? Capital A, capital B, capital C, small a, small b, small c. These are the known quantities. So, we have to calculate AE in terms of known quantities. So, let us work out. BE square plus BO square minus 2BE into BO, and then you can observe AO square plus BO square is nothing but AB square. Again we are using Pythagoras theorem. Then what is BE? BE is nothing but half of the side BC. Side BC is known to you. Side BC is small a. So let us write like this. And then what is BO? BO is written as AB cos B. This side AB cos of this angle B, because this is the base. Okay. Now what is BO? BO you have obtained as AB cos B. Now we will put the values in terms of ABC, and you know the value of cos B as well in terms of a small ABC. So we have substituted the values and we have obtained the result AE square is equal to this much. What next? You have to put this value here, here or here. So let us do further. It is a big question. So finally we have obtained all the values in terms of known quantities, and as I said, the known quantities are small ABC and capital ABC. Okay, so the final result which you will get will be m by 12 and then 3b square plus 3c square minus a square. So you can work out simply what you have to do. You have to substitute the value of AE square and then work out. So this is the final result you will get. Now after that, I would like to take one more question today, because every turn I plan to do at least 2 questions. So the next problem which I am going to do is this, to find the moment of inertia of a rectangle mass m and sides 2A and 2B about a diagonal, its diagonal. So, a very simple question, but this will use, I am going to use the result which we have obtained, that is the moment of inertia of a body about a line whose DCs are known and which is passing through the origin. So, what was that result? This is the rectangular lamina, 2A, 2B. These are the sides. M is the mass. M is the total mass of the lamina. So, what we will do, take this as x-axis, take this as y-axis, and we have to find its moment of inertia about this line. This is the diagonal, making an angle theta with the x-axis. So simple. The result I am going to use is moment of inertia about any arbitrary line passing through the origin, inclined at an angle theta. What is that result? It is A cos square theta plus B sin square theta minus F sin 2 theta. So this is the result I am going to use. This is the moment of inertia about any arbitrary line which is inclined at an angle theta. So what is A? A is the moment of inertia about OX. You know this moment of inertia? Moment of inertia about OX. This is 1/3 of md square. Now what is B? Moment of inertia about OY. It is again 1/3 of ma square. These are the results we have already obtained. Moment of inertia of a rectangular lamina about x-axis and about y-axis. Next term which will come here, F. Now what is F here? F is summation mxy. X, y, these are the coordinates of center of gravity. So here they are 0. So it will be 0. So the required moment of inertia will be A 1/3 of mb square cos square theta plus 1/3 of ma square sin square theta. Now let us see what is the value of cos theta and sin theta. Now in this triangle, you know this side is A, this side is B. So the value of cos theta will be cos theta base upon hypotenuse. So it will be 1/3 of mb square and then cos theta whole square So it is a divided by under root of a square plus b square isn't it? And then its whole square plus 1/3 of ma square and then sine square theta. So it will be b divided by under root of a square plus b square and then whole square. Is that clear to all of you? Now work out this result. You will get 2/3m. Result will be 2/3m. What else? A square b square divided by a square plus b square. So I think this will be the result. Diagonal AC. Of course, that will be the same for another diagonal BD also. So we have taken 2 questions today and that finishes my job today. This is what I wanted to do. Now next time I will be taking 2 more questions, maybe of 3D. Okay, so that's all for today. Thank you very much.